Hello everyone, welcome back to my little video series on Vrui VR application development. And given that the first video in the series is currently going mega viral on YouTube, I figured I would just go ahead and continue doing this and make a second part of the series. So quick recap, last time we are first going to go into our development folder, source, and then hello Vrui. Last time we wrote a little hello Vrui application, which doesn't do very much but print hello Vrui on the screen. We did that in two different ways. This is definitely the prettier and better way. We also talked about, and that was the first thing we did, of course, we downloaded and installed the Vrui VR development toolkit. And so today I want to build on what we did last time, and I want to talk how to actually do some very simple rendering using the Vrui toolkit. And specifically, I want to do some very simple OpenGL rendering, because Vrui is, after all, an OpenGL toolkit, and you're going to get to appreciate how tremendously old school Vrui actually is. So let's just get started without much further ado. We are going to create a new file using our favorite text editor, and we are going to call it whatever, draw opengl.cpp. Okay. Because we're using some OpenGL drawing calls. And then, as always, we start with a little header. Just so when we come back later, we will still know what we did here. And then this one is draw OpenGL. Simple drawing using, immediate mode OpenGL. Now, I don't know how many of you actually have done any OpenGL or are familiar with OpenGL. This is not going to be an OpenGL course, but it's going to show you the basics of, if you know OpenGL, how to do OpenGL in Vrui. Those of you who do know OpenGL might have just read this immediate mode phrase over here and might have suddenly broken out in hives. Don't worry about it. That's how old school and old Vrui is. There's a reason why it still supports immediate mode OpenGL even in 2026. Anyway, as we saw last time, if you want to write a Vrui application, we start by including, and I realized last time that I'm very bad at typing when I talk while I'm typing, and especially when I talk about something that is not exactly what I'm typing into the text editor. So we're just going to have to live with that, and yes, again, make as much fun of me in the comments as you want. It's okay. All right, so we include the two core Vrui headers, the kernel interface Vrui/Vrui.h, and then the declaration of the Vrui application class Vrui/application.h. And then we declare a new application class, and we call that one draw OpenGL. And as before, it is going to be publicly derived from Vrui : application. Okay, and then we have to define a couple of methods of this new class. And the first one, the one that we always need, is a constructor. And the constructor always takes the same kinds of parameters. We have already seen that last time. Draw OpenGL. It takes a reference to an integer, which is the number of command line arguments, and then a reference to a pointer to character, which is going to be the list of command line arguments. And oops, it takes a reference to that. Okay. And I'm just going to continue for now implementing or defining these methods directly in the class declaration because I'm lazy. So the only thing we have to do right now is we have to forward our arguments to the base class constructor, which is the Vrui : application constructor, and then we are basically done. We might have to fill in some things here later, but we are not quite there yet. So then we are going to have to actually implement the functionality of our new application by implementing I should really beam. Yeah, that just didn't go so well. Methods from class Vrui application. We have to implement a couple of the virtual methods that are defined by or declared by the Vrui application class. And we have to implement our old friend from last time, reset navigation. I talked at length about what that one does and what the meaning of it is. But in order to do actual OpenGL rendering, we have to implement the drawing method. And in a reasonable toolkit, that method would be called something like GL render action, but it's not. It's called display. Don't at me. That's what it's called. Okay, so what are the parameters to the display method? And that is something that we will have to talk about at length later, but today just take it as it is. It takes a reference to a context data structure or object, and then most importantly, the display method is declared as const. You cannot change application state from inside the display method, and there's a very good reason for that, and again we are going to be talking about that later. That is a topic for a whole nother video. So we have declared the class draw OpenGL, we have declared the two functions and the constructor that we need. So now we just have to write the main entry point as last time, and you remember that there is this pretty ugly but very helpful macro that is part of the Vrui application header. It's called Vrui _application_run, and it just takes the name of the, oh, thank you, I should have maybe turned off my email. Just ignore anything that's popping up down there. I might have to cut that out. Draw OpenGL and no semicolon at the end because it's a macro. All right. Now I want to continue by defining these methods inside the class declaration. So instead of putting semicolons, whatever at the end, I'm just going to put it in here. We are going to leave the reset navigation empty for a moment, and we're going to start with the display method. So I need to take a little bit of a detour into the history of Vrui. When I wrote Vrui originally, the main purpose of it was to start to being able to develop applications, VR applications for the brand new VR environment that I had access to at the time, which was a fake space immersive workbench, which is an archaeological relic at this time, but in 1988 it was the complete hotness. So I started developing Vrui the moment that I got my hands on that, meaning that I started writing Vrui in April of 1998, so it's coming up on its 28th birthday in a couple of weeks, if I'm not mistaken. So that was the first purpose. And the second purpose was, and this came a little bit later, I wanted to just have some simple way of writing just graphics applications. I needed to visualize some data, I needed to draw some graph. And at the time when I started this, because everybody was working on SGI workstations at the time, I had a trustworthy old SGI 02. I was using SGI Open Inventor at the time, which was an interesting, fun little toolkit. But it turned out you had to write a lot of boilerplate, a lot of stuff just to get the simplest drawing on the screen. And so if I just wanted to draw a graph of a couple of numbers I had collected, it was just way too much overhead. So I figured, you know what, I'm just going to do it so that Vrui is not only good for developing VR applications, but that I can also use it to just do simple stuff. And so the design philosophy became, the initial idea was that Vrui was sort of going to also be an analogon, a better version of GLUT, essentially. If you've ever done OpenGL development, you might be familiar with GLUT. It's the OpenGL utility toolkit. It's a little library that allows you to open a window and put OpenGL code in there. And so I wanted to have Vrui be a better version of GLUT if that's all you wanted to do. And then out of that came the adage that has been driving everything inside Vrui, which is simple things should be simple. You shouldn't have to write 300 lines of code just to put a line into a window. Anyway, this was a lot of talking. So the basic idea is, well, thank you. I should maybe really turn that off. The basic idea is that we can just drop OpenGL code into this display function, and Vrui is going to do the correct thing. So now again, if you're not familiar with OpenGL, or if you haven't done any OpenGL in like 15 years, then this might take a little bit to get used to, but I'm just going to go ahead and start going. The first thing we want to do is we want to set up OpenGL state. OpenGL is a state machine, so we have to make it work for us, and we have to make sure that we are not messing with anybody else. So there's a function call, which is called GL push attributes, where we can save the current state of OpenGL, and then we can start messing with things, and then at the end when we are done we can just reset OpenGL state for any kind of subsequent rendering by saying GL pop attrib. Obviously this is defining a stack of attributes that we can then, between this push and the matching pop, we can manipulate to our heart's content. And the thing that I want to draw right now is I just want to do something really simple. I want to draw a graph of a function, just because that is what what I'm still using Vrui for a lot. And so we want to do a very simple line drawing. So what we do not want is we don't want any kind of material properties. So we are going to disable GL lighting. Okay, and now let's go ahead and do this. Draw a graph of sine of x. I'm just going to randomly pick sine of x over the interval from minus pi to pi. So a full, and this is in radians, of course, so we are going to draw it over the full 360-degree interval if you want to. And the way we are doing this is we are going to draw this graph as a polyline, meaning as a whole bunch of interconnected line segments. And to tell OpenGL that that's what we are going to do is we're going to do a GL begin, GL line strip, which tells OpenGL we are going to be drawing a bunch of connected line segments where each line segment is defined by a start and end vertex, but they're sharing those. So if you want to draw n line segments, we have to submit n plus 1 vertices. And then sometimes later we're going to call GL end to finish that out. So in order to make this a little bit more convenient, I'm going to define a variable, or a constant rather, and I call it num segments, the number of segments we want to draw. And let's just say we want to go a little bit overboard here and draw 1000 segments. So then the idea is very simple. We do a for loop, int I equals 0 I smaller num segments plus I. Oh, and all right, so hang on. We want to draw 1000 segments, which means that we have to draw 1001 vertices, because we have to start the first segment and 2 vertices define 1 segment, 3 vertices define 2 segments. So instead of doing this, we are going to put in a smaller equal. So essentially we are going to go through 1001 iterations of this loop. Okay, now for every point that we want to find out what is the actual x coordinate of this. And in order to do that, we simply convert the loop counter into a double, and we divide it by num segments turned into a double. So now instead of I going from 0 to 1000, I divided by num segments goes exactly from 0 to 1. When I is equal to 0, 0 divided by num segments is 0. When I in the last iteration of the loop is exactly equal to num segments, then x is exactly equal to 1. Okay, so now we have the interval from 0 to 1, but we want to go from minus pi to pi. So we just have to multiply this with 2 point times O, and let's define pi. Because we will be needing that a lot, I have the impression. So const double pi is equal to, and the best way is Vrui has a whole math library built in. And of course of that, it obviously defines the value of pi. So we need to include that, include math constants.h. And because we're also going to be using some math functions, which are defined in just the root math, I'm going to include that one too. Okay, so now we can say double x is double I divided by double num segments times 2.0 times pi. Now it goes from 0 to 2 pi including, and then we subtract pi. And now we are going from minus pi to pi. And then, you know what? We are going to do it the following way. We are going to subtract 1 and then multiply it by pi. You can easily verify that this is the same thing. Okay, so now we have the x argument, and so now we just calculate y as sine of x, and again this math namespace has a whole bunch of namespace global functions which are defined in math slash math.h, and sine is one of them. The reason why I don't just use sine is because this one is overloaded for different scalar types, so you can do it with a double or a float. You don't have to fret about that. That's basically the idea here. Okay, so we have our x and y value, and now we just have to draw the vertex, and for that we use GL vertex 2D, which means draw a vertex using 2 coordinates, and each of those are double values, and just x and y. Okay, and I totally forgot that we need to include the core OpenGL header, gl/gl.h. Yeah, I know, I'm really bad at typing. Anyway, okay, that's more or less it. What I want to do is I want to give this a color. So we say GL color 3f, meaning that we give the color in 3 floating point valued components. And let's say we want to draw this in white. So it's just 1.0, 1.0, 1.0. And then let's say we also want to set the line width at which we want to draw. So we set the line width to 1.0, which means 1 pixel. And because we want to make sure that we're not messing up anybody else, we should also make sure that we save the current line width. So here to this GL push attrib call, we don't only save the enable bits, meaning that OpenGL can undo this GL disable GL lighting call, but also the GL line bit. Okay. All right. So we are drawing a graph and we're going from this, and then we have GL end, and then GL pop attrib. Okay, that's pretty much everything we need to do. So now it's time to fill in our reset navigation method. And if you remember from last time, we are going to define here what our area of interest is, so that Vrui can then go ahead and no matter what our VR environment is configured like, no matter what our window position and size are, it will show us the area of interest in the window. And that function call is from the Vrui kernel interface, is set navigation transformation, and we are going to be using the version of this that takes a center point. And because here we are drawing from -pi to pi, and then the sign goes from -1 to 1, this happens to be centered around the origin. And then we need to give it a size, a radius, of our area of interest, and I'm just going to put in 4. And then we can give it a vector that we want to be up. And because here our graph is in the x and y plane, and x is supposed to go to the right and y is supposed to go up, we can just say Vrui : vector and then 0, 1, 0, which is the y direction. That will tell Vrui to make y go up. So then we put a comment there, center on the drawing, and have the y-axis point up. Okay, and that should work. That should basically be all that we need. So we're going to save this, and we are going to, yeah, thank you, I don't want to update my system now. And now we are going to build that. And last time what I did is I didn't change our makefile at all. I just, every time we build our hello Vrui, I had to type make hello Vrui. And let's today talk about how we can put something into our makefile so that it gets built in a more sane way. So we are going to edit our makefile. And then we don't have to change anything up here. But last time I briefly talked about this all, where we specify all of our final targets. And so this is what we're going to do here. It says use $exedil/ before executable names. So we are going to put that in there. And then the name of our executable is going to be draw OpenGL. Okay, so now the makefile is going to automatically build that. And so then we are going to put in the build rules for our executable all the way down here at the bottom. And I'm going to just copy this and put it down here. And so now it's the usual makefile rule. So we're just going to give it what are the files it depends on. And in this case, I'm not going to put in the source file because the executable doesn't actually depend on the source file directly. It depends on the object file that results from compiling this. And the automatic compile commands that are part of this make system put the object files into $object_dir. And so inside there is going to be a draw OpenGL.o. So we are going to be doing this. And then the last thing is, because maybe at some point I just want to say make draw OpenGL, I'm going to make a phony target, call it draw OpenGL, and then make draw OpenGL depend on the actual executable. Okay. The other thing I mentioned last time is we set packages to Vrui all, which means we are going to link against all of Vrui. I said like it's a little bit of overlinking, but don't worry about it. So let's today talk about how to do this correctly. So I'm going to leave this default setting, but we're going to overrule the packages assignment for this particular application. So we're going to say packages equal. And so now we have to list all the packages that we are actually using. And that's very easy to find out. We are going to be using the math package. We are going to be using GL, and we are going to be using Vrui. So we put them in reverse order, and the packages are my Vrui, my math, and then just OpenGL. Why is there a my in front of Vrui and math? That's just a legacy. I should really rename that to Vrui _ whatever, but I have just never gotten around to it. Just roll with it. Okay, let's save our makefile. And then let's build our application. And now if everything worked correctly, we can just type make, and it's going to do the correct thing. And wow, I'm amazed, it worked. Ha! No typos, no missing features, nothing. It just worked. Well, we don't know if it worked yet, but it compiled. Okay, let's have a look at what the contents of our directory are now. Because here, before we had hello vrui.cpp, the makefile, the share subdirectory where I put the vermel file that hello Vrui used, and then the bin directory where all of the executables ended up. So let's do another listing. And so now we see we have a couple more things. We have our new source file. We have draw OpenGL.cpp. We have a subdirectory called O. This is where all the object files go. We have a subdirectory called D. That's where all the dependencies between our files go. The make system does its own dependency management. And then we have bin as before. So let's have a look at what's inside bin. And to no surprise, there is an old thing in there that I was messing around earlier. Let's get rid of that. Bin draw graph. I didn't clean up after myself. So let's do it again. So now we have draw OpenGL and hello Vrui. And what is in O? There's a subdirectory called g++-3.g0.03, and under that are the actual object files. The reason here is that you can have different settings for your compiler, and so all of these object files with the different settings can live side by side. The g0.03 means that this is no debug information, high optimization. If I were to enter debug mode, it would be full debug information, zero optimization. And then G++ just means compiled with G++, and -3 means compiled with version 3 or newer of G++. So this tells you how ancient Vrui is, because when I set up this whole build system, there was a big change from G++ version 2 to G++ version 3, and as part of that change, they broke ABI. And so I had for a long time, I had to live with the fact that some of my computers were still using G++2 and others were using G++3, and they had to live side by side, so I had to do it this way. I think we're now in G++ version 15, so that is all ancient history. Anyway, that was a tirade. Let's just run our draw OpenGL program and see what happens. There we go. And well, will you look at that? It's a sine curve. But, you know, it could use some refinement. We don't have coordinate axes. It looks pretty bland. There's a lot of pixelization. Let's fix all of that. Okay, let's go back to the drawing board and let's draw coordinate axes. Okay, so let's put that here. Draw coordinate axes. And so now I'm going to draw those at the line width of 1, so we have to pull this up. And then we're just going to draw a couple more OpenGL lines, but now we're drawing individual lines. So we are saying GL begin, GL lines, and then of course followed by a GL end. And let's say I want to draw these lines in, let's pretend that we are on an old school CRT monitor, because everything is old school. Today we're going to be drawing them in dark green, and I just messed up. This is supposed to be a 0. Okay. All right, so what do? Let's start by drawing the x-axis. So in order to draw a line, you have to specify 2 vertices. We are going to be using the same command as before, gl vertex to d. And then we're going to draw this from, let's say, -3.3 in x and 0 in y, and then all the way to +3.3. Because we are going from -pi to pi, so let's have some overshoot. And then let's also draw the y-axis. And the y-axis goes from -1.2. We want to have some overshoot. There's, oopsie daisy, wrong. Ah! Kept pressing the wrong key. We want to go from that to +1.2. Okay, let's check that. So now I'm going to run make again. And in order to then run our program immediately after, if the make succeeded, I'm just going to put 2 ampersands and then draw OpenGL. In this case, if the make fails, it will just fail. If the make succeeds, it will immediately run our little program. And here it looks a lot better already. Okay. Yeah, that is pretty good. Let's be a bit more fancy. Let's put little arrows on the ends of our axes. I mean, this is overkill, but I want to show you that you can do all of this stuff with fairly small amounts of overhead. We are going to be drawing a lot of lines, and I don't want to be typing out these GL vertex things all the time. So what we are going to do is we are going to define a helper function or method, private methods. And it's going to be a static one, and it's going to be called draw line. Or you know what? I'm lazy. It's going to be called line, and it goes from double x0. So we are going to just give it 4 coordinates: x0, y0, x1, y1. Draw a line from x0, y0 to x1, y1. Okay. Let's do that right away. We can simply put in GL vertex to D x0, y0. and then X1, Y1. So if anybody is wondering why I'm having such a hard time sometimes finding keys, I have a keyboard that has no key labels on it. That was sold to me with the idea that it's a much better way to learn typing, because you learn not to look at your key labels because your keyboard simply doesn't have any. So all my keys are completely blank, but it turns out it didn't really work for me. What can I say? Anyway, so now that we have this line method, we can just shortcut this. We can, instead of doing this, we can just use line and then put a comma here and we are good. And then we're going to do the same thing here and put a comma here. And am I missing something? Why is this not properly aligned? Oh, because there's supposed to be a space here. I want to make this line up. Okay. All right, let's draw an arrow. So how do we do that? We're going from -3. No, we want to draw the arrow on the positive. Oops, I could have kept that. So we're going to be drawing from 3.2 and then a little bit down in the Y to 3.4 and 0. And then from 3.2 and a little bit up to that same thing. And then we're going to just repeat that for the y-axis. So we are going to be drawing from -0.1 and 1.1 to 0, 1.3. And then do the same thing here. Let's run that. And, oh, haha, awesome. Yeah, it's a lowercase d. Okay. Thank you for that error message. Here we are. Look at that. Beautiful. Okay. Still pixelated, but beautiful. All right. So let's go from here and get rid of the pixelation. And I'm going to show you how the easiest way to do that. And this is going to tie into something that we actually did the last time. And as when it comes to drawing things, this is pretty much what I wanted to go over today. But the second topic I wanted to cover today is Vrui's desktop interface, because you're going to be seeing a lot of that. The nice thing about Vrui is you can develop even your VR software without typically ever putting your headset on until you're really ready to test things, because the desktop mode of Vrui is full featured. You can just develop your stuff in there. And you don't have to headset on, headset off, headset on, headset off. I find that super annoying. So that's why it is set up this way. So we're going to talk a little bit about how that works. And as the first step of doing this, I want to talk about how to configure Vrui on the fly and how to get rid of all these little jaggy artifacts. Okay, so let's shut this down. And I want to show one other benefit of setting up the make system in this way. You notice that here when I ran make and draw OpenGL, it ran make again. It recompiled draw OpenGL and then linked draw OpenGL. In the way that we did it last time, every time I typed make hello Vrui, it would just recompile and link hello Vrui. But now if I just type make, nothing is going to happen because nothing changed. That is because the make system does automatic dependency management. If I change something like this and then say make, then of course it's going to rebuild. That's no big surprise to anyone. That's the whole purpose of make. I just wanted to point out that if you don't put your targets in your make file and you do it like we did last time where we had to say make hello Vrui, it's going to recompile and relink every time because it doesn't keep track of dependency information. That was just a little aside. Okay. But what I really want to do is I want to show how to turn on anti-aliasing in the easiest way. Vrui is configurable to a somewhat insane extent. It is severely over-engineered. And it is done via a series of configuration files that are just text files. You can edit them. But you can also override configuration on an individual setting basis by passing this setConfig argument on the command line of any Vrui application. And then in quotes, you put the configuration tag you want to change. We have already done this last time. Remember, at the very beginning, we changed the font size once. But here we want to change the multi-sampling mode of a window. And so here I go into a window section. The configuration space in Vrui is hierarchical, and you talk to it essentially like path names in Unix. So it is window, and then the setting in the window setting is multi-sampling level, and then we set that to 16. The default is 1. And if you now run it, you're going to see a beautiful anti-aliased super sampled display. This is I don't know how good this looks in the video, but here on my screen it looks beautiful. There's one thing I want to change. I want to make the graph use a wider line. I want to use a line width of 2. Let's do that real quick. Okay, let's copy this down here. Quick reminder, the GL line width has to be outside the GL begin, GL end pair. GL color is supposed to go inside, but it can be outside, but GL line width has to be outside, can't go inside. Quick reminder. Okay, so let's rebuild this. And voila, we now have a beautiful anti-alias 2-pixel wide line. Fantastic. Okay, this covers more or less everything I want to do in terms of actual rendering for this iteration of the series. But let's talk about the things you get for free when you do things like this in Vrui. Okay, let me close this down real quick and let's have a look at what we actually wrote. So this entire program is 84 lines long. And what is the ratio between stuff that actually does something versus overhead? And I would say that is pretty effing good. We have a comment at the top, which we really shouldn't count. We have to include a bunch of files. We have to make a class. And then inside that, we have a little helper function. We have a constructor. It's just one line. And then we have the display function, which actually does stuff. There's a little bit of boilerplate here. There's a little bit of boilerplate at the end. But then it's just straight up drawing code. And then we have the reset navigation, which is just one line that says, hey, center the display on this. And then we just call the macro Vrui application run. So if I had taken out all the comments, we would probably be more like at 50 lines. And I think that is pretty good. So this is what I meant by, simple things like drawing a graph of a sine curve. Sine function should be simple. You shouldn't have to write a 300-line, 400-line piece of source code just to get a simple drawing like that on the screen. And this is the reason why I literally, since I started developing Vrui, haven't used any other toolkits of doing quick graphics. I haven't used Glut since then. I haven't used most of the plotting programs like gplot or the other ones, because I'm just, when I have to draw something, I just hack out a little Vrui application because A, it's very easy. I of course know how it works. And B, if you do this, you do get a bunch of stuff for free. So let's have a look at what we get for free. Let's rerun this. Well, one thing that we get for free is anti-aliasing, obviously. The other thing that we get for free is I can drag the window around. I can change the scale of the window, and you'll notice how Vrui does the right thing. As I make the window bigger, it makes our display bigger, but it never changes the aspect ratio because it knows that aspect ratio is important, that we want to preserve that. You notice how it doesn't always keep everything in view because the way it's set up. That is something where I have an idea of how to change that by making a new version of this set navigation transformation method that takes a box of interest instead of a sphere of interest, but don't worry about that right now. But it basically does the right thing. If I hit F11, the whole thing is going to go full screen, and you notice no window borders, nothing. This is perfect for taking screenshots or making screen recordings. If I hit the maximize button, it's going to be semi-full screen. I still have the title bar on top. So we get all of this stuff that you would have to code extra if this were a Glut program. You would have to have your callbacks for window size changed. You would have to recalculate your OpenGL projection matrices and your model view matrices. Note that we never set up any of that. We just wrote straight up rendering code. There's no window setup. There's no setting up of any matrices. Vrui does it all for us. We just have to put in the 3D stuff we actually want to draw. The other thing we get for free, and we already saw that last time, is that Vrui has built-in viewport navigation. So we can just, by using the left mouse button, I can click that here and I can rotate the view around, which is, of course, since we have a 2D display, is really pretty dang useless. But Vrui doesn't know that, so it gives us the option. If I find myself in a position where I am not quite sure where I am, I can just reset that, either by holding down the window key and pressing home, or, and we already looked at that yesterday, I can bring up the main menu by pressing and holding the right mouse button and then going in here and saying view, reset view. So all of that, comes for free. The mouse navigation tool doesn't just rotate, but it can also pan in the screen plane, which in this case is going to be much more useful. If I want to have a close look at, let's say, this point over here, I press and hold the middle mouse. I press and hold the Z key, all right, and move it over. Z is just picking up a point and moving it around in the screen plane. Why are we using Z and not the middle mouse button? Well, that's a bit more historical interest. For the longest time, Vrui was supporting macOS, and on macOS, those poor people, they can't afford middle mouse buttons, so we had to use the Z key. But it turns out that we haven't been supporting macOS since Apple decided to ditch OpenGL, and then maybe even intentionally introducing bugs into their OpenGL implementation. So that's when they decided to not support them anymore. So this is really is a legacy thing. And you know what? We're going to change that right now because it's really bugging me. I want to use the middle mouse button to pan around. Okay, before we go any further, let's do that. So I mentioned that Vrui has a bunch of, that configuration is done via configuration files. And those configuration files are in the Vrui installation directory /opt Vrui 14.1 was what we downloaded last time. And then there's etc. And you see there's a whole bunch of things in there. And the core configuration file is, no surprisingly, called vrui.cfg. So let's edit that with a text editor. But oh, it's in a system directory, so we can't use that. We have to use another text editor in sudo mode. We could run Genie in sudo mode, but I don't like that. Here's where I would be inclined to use VI, but I have recently been told that I should be using nano, so let's do that. Oh, and then of course vrui.cfg. There we go. Oh, yeah, I have to enter my password because it's sudo. Okay, so here's the central configuration file, and as you can see, there's a section Vrui, and inside of that is a section desktop, which is the configuration for desktop environments. And this is where everything happens. And you can see that this is, again, slightly over-engineered. Every single thing, there's nothing hard-coded in Vrui. Every single thing is configurable through the configuration file, like the name of the pixel font and the font height and the background color and all of that. And here's the UI font text height setting that we changed last time in order to make our message more readable. Okay, but the setting that we do want is in the tool section, and I haven't talked about tools yet. We're going to get to that later, but don't worry about that right now. There's going to be a section for all the default tools that are bound when a program starts up, and the mouse navigation tool is one of those default tools, and here it is. It is tool class mouse navigation tool, and look at that, there's already a comment in there where it says replace Z in the following binding with mouse 2 to use the middle mouse button. So let's just go ahead and do that. Mouse 2. And then we save that using Control O and write it to that same file, and then we go out, and you notice that that file is very long, 1970 lines, and we're going to go out with Control X. And so now if we run our application again, we'll be able to use the middle mouse button to pan. Perfect, look at that. Okay, and this should really be the default setting, and I guess at some point I'm going to change it, but I haven't changed it yet. So quick reminder, left mouse button rotates in sort of this virtual trackball-like fashion. Middle mouse button pans. Right mouse button brings up the main menu where you can do all kinds of things. And then how do you zoom in or out? And there's the fine way and the coarse way. The fine way is you press and hold the middle mouse button, and then you also press and hold the left mouse button, and then you move the mouse up and down. And it's just going to zoom in or out. And you notice, you may or may not notice, that the zooming happens around the center of the window, the intersection of these two white lines here. So if you want to zoom in on something, the idea is always you bring that thing to the middle, and then you zoom in by middle and left, or first left and then middle, doesn't matter, and then moving up or down. And because zooming is a very common thing, and all of our mice have mouse wheels on them, we can just roll the mouse wheel up and down and do it the same way. Side note, we had an event on campus the other day, and the inventor of the wheel mouse was there. So I got to talk to him and say, hey, a wheel mouse? Crazy, I got one of those. What are the odds, right? Anyway, so you can zoom in or out by just rolling the mouse wheel up and down. Okay, so that's the navigation tool that we get. So we get all of this stuff. We get all of this stuff for free. Let's have a look at some of the other view-related things that we have in here. If I go to the view menu, then obviously there's the reset view. We already know that. But then there's also you can fix the orientation and fix the vertical. So what does that mean? If I currently use the mouse to move around, it can rotate around any axis. I can rotate this way, I can rotate that way, I can rotate around any oblique axis. So because this is meant for 3D viewing, obviously. But in this case, I might want to keep the y-axis always pointing up. So what we do is we first reset the view, and then I can go to view and say fix vertical. And now if I rotate with the mouse, you'll notice how the vertical stays in place. And in the same way, I can fix the entire orientation, which now means if I use the left button, it doesn't rotate at all. Why is that there? Because sometimes in a 3D environment, that's actually really useful. So let me turn that off. There's also the thing where if you accidentally change your view and you just really messed up what you just very carefully did, you can go to the view menu. There's an undo function, just undo, and it goes back to the last thing you had. And I don't want to talk about too much what's going on here, but the last thing is there's this align view submenu. And here's where you can sort of pick canonical views. You can align the view with the X and Y plane, which we already have, so nothing changes. And then you can align with X and Z. So X goes to the right and Z goes up. So now we're going to look at our graph from the top. And you can now imagine what align view YZ does. You can also just align a direction. You can say whatever the current direction is, but have the Y align with up or down, depending on what it's closest to. Here we go. I'm going to reset the view. So you kind of get the idea. And then once you have it, you can also just flip the horizontal, flip the vertical, or just rotate the display in the screen plane, counterclockwise or clockwise. These are all, really, really simple things. I want to reset this. I don't want to show you all the features you get, but just be aware that there's a bunch of stuff that comes for free. What else do we have? There's a devices submenu, which we don't really need to use at this point, but I wanted to point out one thing. Some of you might have been wondering what that little red box down here in the corner is, and that is the tool trash can. We have already seen how Vrui uses tools to bind user interface actions to buttons and keys on the device. And we have changed that configuration file so that instead of using Z for panning, we now use the middle mouse button. But it turns out you can also change these bindings from inside the program. And the way to do that is you can essentially delete a tool by just clicking a button in this red box, and then you can reassign the tool. You know what? We're going to do that right now, because here's a good example. The way that the mouse navigation tool is set up now is that left mouse button rotates and the middle mouse button pans. But since we are looking at a 2D display, that's really inconvenient. I want to use the left mouse button to pan and then the middle button to rotate, because the middle button is obviously a lot harder to press than the left mouse button. So here's how we do this. Right now, the mouse tool is bound to the left button and the middle button and the shift key. I haven't talked about that yet, and the mouse wheel. So what we do is we first reset the view. And then we can click any of those buttons in the tool kill zone. And if you click and hold a button, it will show you what currently is bound to that button. And it shows me to the left mouse button, we have a GUI interaction tool, haven't talked about that. And then the rotate function of the mouse navigation tool. Okay, so this was when I click and drag outside of the tool kill zone. If I just click and release in here, the tool that's bound to the button is going to disappear. So now if I click the left mouse button, it won't have a function associated, so it doesn't do anything but show me the tool selection menu, because Vrui sees that, oh, there's no function to the button you just pressed. Let me help you out. Here are all the tools you can bind to that button. And so we are now going to rebind our mouse tool, but we're going to do that by first pressing and holding the middle mouse button, because the first function we are going to bind to our mouse tool is the rotation function. And then I go to navigation, and then here's the mouse multiple buttons tool, and then let go of the middle button. So now the middle button is bound to the rotate function, and then Vrui realizes that this tool has multiple buttons that also need to be bound, and so it asks me to please press the button to assign to tool function pan. And this is where we want the left button, and then it wants to switch the button or key that switches between zoom and dolly mode. We haven't talked about that yet. That's the shift key. And then finally it wants the valuator to assign to tool function quick zoom dolly. And a valuator is like an analog axis, not a button. And the mouse wheel is the one that we want to bind here, because in Vrui the mouse wheel is represented as a analog axis, because depending on how fast you spin it. So I'm just going to roll the mouse wheel up and down, and here we go. So now we have rebound the mouse tool, but now the left button pans and the middle button rotates. So this is much more appropriate for doing 2D graphics like this one. So what you just saw is essentially Vrui's version of changing the key bindings of keys directly inside the application, which you can do in every game going through the settings menu. And here it is much more deeply integrated in that it's really part sort of off the VR world itself. And yeah, this even works inside VR. You can bind functions to buttons on your input devices in the exact same way that we just did. And so that was a long sidetrack talking about mentioning the fact that this red box down here is the tool kill zone. And so in the devices menu, we can turn that inactive if we don't accidentally want to erase our tool. So now if I click on there, it's just going to be the same as if I click anywhere else. And then if I don't want to show that thing, maybe because I want to take a screenshot, I can just turn off showing the kill zone. And now it looks pretty like a pretty regular 2D application. Okay, what else can we do? If we click the right mouse button, we are in the Vrui system menu. So we saw the view and the devices submenu. There is the scale bar. We have already seen that last time. It's essentially a way of, it's a map legend, a scale bar. So right now it shows us that our scale is 3.5 to 1. If I zoom out, the bar is going to get longer. And now it shows us that, the length of the bar is, and the number on the bottom is 5. And so from here to there is 5. That seems about right because our graph goes from minus 3.14 to plus 3.14. I can also click on the ends of the scale bar, in which case it goes to the next map scale. So it's 1 to 1, 2 to 1, 5 to 1, 10 to 1, or I can zoom out by clicking on the left, 10 to 1, 5 to 1, 2 to 1, 1 to 1, 1 to 2, 1 to 5, and so forth and whatnot. And the scale bar scales around its own center. So if I bring the display directly into the center of the scale bar, it's going to stay in place. If I move the scale bar all the way over here and zoom in, then the thing is going to move outside the screen. That is intentional. It turns out that it's the best way I found of doing it. Okay, that's the scale bar. And then the last thing we have is the Vrui settings. We already looked at those last time. We can change the measurement unit. We can change the light sources. We can add an additional sunlight source and place it somewhere. Each viewer has a headlamp. This is not important right now. And we can change the graphics, which is like the background color, the backplane, front plane distance. Here's a fun little thing. If I show the scale bar and then I change the background color, look closely what happens to the scale bar. Oh, missed it. Here we go. It's currently white and then it turns black because it figures out it wants to have maximum contrast with the background. So there's, a little bit of smartness, of functionality built into all of this. Okay. So this was the stuff that's available through the system menu. The last thing I want to show is that there's a whole bunch of other tools that you can bind. And because we haven't created any specific application tools, we're going to do that in a later section of the series when we talk about how to do user interaction. But I can now press any button or key that currently doesn't do anything, and I have run out of mouse buttons, so I'm just going to press and hold a key on the keyboard, like 1. And what happens is the tool menu shows up because 1 hasn't got a function associated to it. And then I can pick a function. And for example, if I want to take measurements in my 2D scene or 3D scene, I can use an annotation tool. And this creates a little dialog window. And now if I press and hold 1, I'm going to do annotations. And I interact with this dialog box in the same way just as a regular desktop system would by using the left mouse button. So I want to measure, let's say, the position of a point on the graph. I click on position and then I move over here, and then I don't click the left mouse button. I click 1, which is the button or key to which I assigned the annotation tool. And look at that, there's now a measurement marker with the exact coordinate of that point displayed. And of course I eyeballed it, so I was a little bit off. I can just pick that up again with 1 and move it around. And of course this is an XYZ measurement, so I have my X and Y coordinates are meaningful. And for some reason the Z coordinate is minus 1.8 times 10 to the minus 15. Yeah, that should probably be rounded to 0. Just, yeah. If I want to do another measurement, I can say I want to measure the length. I want to measure a distance from all the way over here to all the way over here. So I'm just going to click once, drag it, and then, oops, biffed it. But you can see it's 6.2 whatever, which is pretty good. So I'm going to zoom in here because I accidentally didn't let go at the right time. Put that marker right there. And then if you zoom out, that should be now 6.26 something something. So I didn't get it exactly, but close enough. Let's fix it up. This should now be, oops, still didn't get it. Okay, this should now be more or less exactly 2 pi. Zoom out, and here we go, 6.28. Perfect, looks like 2 pi. Okay, so that is what I wanted to show about the desktop interface, that you can create these additional tools which are more or less useful. Actually, let me get the tool kill zone back so I can get rid of this tool. This tool the development of this particular tool has been abandoned because there's now a better version of this in the collaboration infrastructure, but we're going to talk about that later. So if I want to get rid of this tool, which will also get rid of all these measurements, I just press and release 1 inside the tool kill zone. We can now make another tool, let's say the curve editor, which is the simplest of all possible drawing tools. Press and hold 1, and you can just freehand draw in 3D. Let me spin this display. Here we go, and then we can draw. That is spinning a little bit too fast, but you get the idea. We now have drawn just a bunch of things in 3D. It's pretty fun to just annotate things using freehand drawing in 3D. You can also draw polylines or brush strokes, which are like these, wide brush strokes. Now, because this is just a 2D input device, it doesn't look like much, but you get the idea. If I want to get rid of all of this, I just delete the tool and be done with it. Okay, so enough of that. What have we done today? We have looked at ways to do some very simple drawing using immediate mode OpenGL in Vrui, just in order to show that there's actually really small amount of overhead to get something simple like that on the screen. It's totally worthwhile to just, at least I find it worthwhile to just do essentially all my drawing that I need to do inside Vrui. I have made little videos and animations that I ended up all programming in Vrui. I made this one animation once that shows the solar system to scale, the Earth, Moon, Sun system to scale, and I did the whole thing in Vrui because it was super easy to do it that way. We haven't talked about animation yet. I think we're going to talk about animation maybe next time. What is the last thing that I want potentially to mention? Oh, right. Some of you might have broken out in hives a while ago when I mentioned immediate mode. Because immediate mode is such an old school thing to do, and as everybody knows, immediate mode is super duper inefficient, so why are we even doing that? And the answer is because we're not running this on phones, we are running this on a relatively decent computer, so we just don't have to worry about it. But this might be a good time to show how we can do some very quick and dirty performance measurements in Vrui. So I'm going to go back to this, and I'm going to just turn off anti-aliasing for a moment, just do draw OpenGL. And so now there's a way to turn Vrui into burn mode, in which case it just runs frames as quickly as possible, means it renders as quickly as possible, and then tells me what frame rate it achieves. In order to do that, you hold down the Windows key, and then you tap scroll lock. And then it tells you I'm entering burn mode, and then it tells you I'm now running at 143 frames per second. That is very strange, because it should be running at 60, because we should actually be v-synced, but obviously and apparently we are not, and I have genuinely no idea why we are not. But anyway, we're running at 140 frames per second, which is really, really low. And you can just hit Windows and scroll lock again, and it's going to tell you the exact average frame rate over the entire time you did it, and also the frame time range, yada yada yada. So we were running at about 144 frames per second, which is ridiculously low. So why is that happening? Let me do a quick test. We are going to be drawing a lot of segments. Let's draw 1 million segments, which is total overkill. And let's see what happens then. So what is going on here? And now I'm going to go back to burn mode. And it's running at... Oh, I think I know what's going on. Okay. You notice we are now drawing 1,000 times more stuff. We are drawing 1 million line segments in immediate mode. And we are still getting 55 frames per second. So we should have been getting more like 55,000 frames per second when we had only 1,000 line segments, but we didn't because I'm running the screen recording in the background, which is doing video encoding on the graphics card, which is probably interfering with our OpenGL performance. Now you have to take my word for it, but if I do a simple drawing, like, and I've done this before, if I draw like 1,000 line segments in immediate mode in a window on my computer here, I get about something like 15,000 frames per second if I disable VSync. So the point being that if you're doing something as simple as this, OpenGL immediate mode is perfectly fine. We are going to talk about how to, use caching and vertex arrays and vertex buffers and all of that in a much later section, in a much later iteration of this little series. For something simple as this, there's just way too much overhead to use caching and graphics card memory management. And as you can see, Even at 1 million line segments, we are still getting 54 frames a second. So it's just don't worry about it, is what my point is. Okay, now do I close here, or do I want to use the chance and talk a little bit about the user interface in VR mode? No, let's not do that. We have already run pretty long. Let's keep that for a future installment. So, little recap, what did we do today? We wrote a very simple program that uses immediate mode OpenGL to do some very simple rendering, like in this case a graph of sine of x, just to show that this is very straightforward. You can just directly put your OpenGL code into the display function of a Vrui application, and it's just going to do the right thing. You don't have to set up your windows, you don't have to set up your projection matrices, you don't have to set up your viewing matrices. Everything is just taken care of. Under the hood, of course, the viewing matrix is behind the scenes set up by Vrui based on the information you give it here. I mean, that's not a secret I'm spilling here, but that is where we are. So doing OpenGL rendering is super easy because that's what Vrui is also designed for. And then we also saw that Vrui can essentially be a GLUT replacement, but it has a bunch more functionality than GLUT because it has navigation built in, meaning I can change the view, I can zoom, I can pan, I didn't show you, I can save the view and load it back later. All of those things that are really, really useful. You can draw on the screen, take measurements, all of that stuff. The main point here is I have stopped using GLUT the moment I had Vrui in the working state, and I have never ever looked back. Yeah, so I think we're going to wrap it up today. And I will hopefully see you in the next installation of this little series, and I hope that you find this useful and that there was a little bit of fun. And I'm also hoping that you are actually following along at home and actually coding with me as I'm doing this, and not just sitting there and laughing at my terrible typing. All right, so have a great evening, and see you guys all later.